If these ripple paths are from the center of the stream, then where does that mean that the riverbanks were? The riverbanks were the walls of the canyon that it sits in. That was once filled up bank to bank as a raging river, and the ripples were just made afterwards from the decrease of that river. And that's why we find mesas around rivers that are actually streamlined, right? So they're the streamlined intermediaries that didn't get washed away completely but remained after the water carved away everything else. And that's why the mesas are covered in cataract features. A cataract is a big U shape made by a waterfall. So what do all these ripples tell us? Well, they let us know that a water level washed off of all of these deserts. That's the only way these ripples can form, especially because they're found in river paths. So that's not something people normally think about when they study the desert, but it's a very apparent feature once you start looking for it. This allows us to understand the desert better, to understand its erosional features and its depositional features, such as these massive debris fans, which can only form by a water current and can only form under a water level. We can know that for certain because of the shallow slope of these fans. Only water can deposit such a shallow slope, even at a slope of less than 1 degree. But without water, the fans tend to take on a much steeper slope of at least 30 degrees. So that's how you can tell the difference between a fluvial fan and a non-fluvial debris fan. You can see the water just pulsating right over it, ever so gently of a slope. But these slopes here are much steeper and are from landslides and mudslides. So when we look at our ripple patterns, we find them very commonly on these fluvial fans. And that's kind of why they're braided streams, because when they flow over that cone shape, it likes to separate the river into a braided stream formation. And they're very, very shallow features. Also, our spot in Australia, one of them has all these ripples on top of a debris fan. That's a fluvial deposit next to two massive ones. But these fans aren't really in any place you'd expect because they're over incredibly flat terrain. And same with the one we find in Argentina. We find a massive one nestled right up against that ridge. And Brazil also has massive debris fans. So this indicates massive amounts of erosion happening or deposition rather, happening at one time. And all underwater. Which means that these drumlins also formed underwater as well as all these ripples and fluvial lobes that are in this formation here as well. So a very fundamental idea of fluvial dynamics is that erosion happens above a water line and deposition happens under a water line. And so the stream paths, the braided stream formations, are erosion that happened after the deposit, and the ripples happened as it was decreasing, as it was transitioning between the two. So this is an example of erosion, eroded stream paths. And then here we can see where the water line was based upon that cliff and the dividing boundary between erosion and deposition. So when we look at our example of braided ripple formations, we also see that this was over a large fluvial fan as well. And that's why the river was able to separate into the braided ripple formation, because there's a slight cone shape to that feature there that formed when the ocean was covering it. And another feature we find on these landscapes are sediment lobes, which are those kind of pointed features. And we can see how a water current can push the sediment forward in a lobe-like formation. And this happens in sheet water flow, where the entire width of it is underwater. So when we look closely, we can see all of those lobe features that were connected to it and that were made when the current was just barely underwater. Here's an example of the Deschutes River entering the Columbia River and adding all that debris and made sediment lobes. And so when we look at these ripples here in New Mexico and how they're on a massive deposit that's nestled up against this ridge, when we go over to the other side of the ridge, we find White Sands, New Mexico, and that's covered in sediment lobes. So that indicates a current direction. And then when we go to Columbia and we look at this example, we see that it's not too far from these sediment lobes, which show a current of inland direction. So this was actually the ocean washing inland. Very interesting. And there's sediment lobes all over Brazil pointing to an inland direction. And at our spot in Argentina, we also find sediment lobes. Those light brown lobes are actually pushing upwards. Right here, you can see them pushing upwards towards that mountain peak. And in Canada, where we see in the streamlined mounds and all sorts of fluvial deposition, we see that the mounds are streamlined in a direction that actually goes uphill in this case. It's gaining elevation up to that ridge. So it's showing basically a sweeping current that really doesn't care too much about minor elevation change, right? This is a major feature of sheet water flow. Now, another feature we find in sheet water flow goes perpendicular to the ripples. And it goes perpendicular to the ripples, but parallel with the current. These are called parallel path features. And they're also called drumlins as well. And we find them in Somalia too, right next to where we find all of our ripples. So we see fluvial features of a decreasing water level, which is the ripples, and then the drumlins are actually more impressive. They show a deeper water level and a more swift current to make those parallel mounds, which are parallel drumlin features. And in Canada, within the canyons that have all the ripples, we find that the larger terrain is showing a path of drumlins that curve in towards the Hudson Bay. So these are very correlated with drumlins, which are a directional feature. And in Russia, there's a great location that shows lots of streamlined mounds on this hillside. And this is the same location that also has the same type of ripple formations. And right next to these ripple formations, in the lower left-hand corner of the screen, you can see drumlins. So there's another example of the correlation between these features and drumlins. Both have to do with lots of water moving. And then we zoom out from this landscape, go way out into space to get the full thing in frame, and we see massive parallel paths of canyons that show that a current just ran right across with a massive amount of sheet water flow. And it created all of these scab lakes, which are now salt lakes, which indicates that the current was that of an ocean current. And these parallel path features dive right into drumlins being also parallel path features of sheet water flow as well. And then, of course, we have to recognize what is in Australia: massive drumlins, lakes, and ripples. Same thing in Arizona and in Utah as well. These are kind of more of sediment lobe / drumlin features going inland as well. And then in China, we can see these parallel paths. You can imagine how the current swept and curved. They make it easy to see exactly where the current goes because they go parallel. It's very simple. Very simple, yet very big. Same thing in Africa as well. All those little scab lakes. And these drumlins also cover vast, hundreds and hundreds of miles of this terrain over flat land. So it makes it easy to see what sort of erosion the earth had once we consider these drumlins, which are very correlated with my favorite type of ripple formation, the braided ripple formation. These drumlins make it easy to see that they're responsible, or that the ocean current is responsible for them. Okay, thank you guys very much for watching.